to do, it's a quick view of the controls of the systems on the overhead panel. Let's start from the flight control panels. Here we have the flight controls A and B. Normal flight controls rather are powered by system A and B. If system A or B fail, one system A or system B or both rather must be powered by the system standby, putting this switch on standby rudder. This is the alternate flap switch. And you put an arm, you can operate an alternate flap for 15 or 40. Normal use for alternate flaps is flaps 15. And the leading edge, when you put this switch down, put here, its leading edges go to full extended position. Your damper, the switch of your damper, the spoiler switch on and off, normal uses for maintenance purposes. Here we have the navigation switch to transfer the systems from one side to another side. And the displays for the DEUs and DUs. Here we have the panel from fuel. We have 6 pumps. We have 3 tanks in this aircraft. Left main tank, right main tank, and central tanks. Normal usage, we are using the main tanks because you don't need too much fuel for the flight. Fuel pumps in the center has on and off position. On position, we just turn on when you have fuel more than 500 kilograms in center tanks. And after pump and forward tank for the left tank, tank, you have position on and off. If you have low fuel, you have low pressure. It's the same occurs when you put the switch to off. Okay. Continue, here we have the electrical system, the battery switch. Now you can hear the battery conditions and the standby power. We have 400, 115 the voltage and the frequency. Battery it's 27. And the galley power switch off and on. We have the electrical panel and standby power, and here you can disconnect the IDG. Switch for generators, you put on and off for the IDGs and for the APU generators. Okay. Window heats, switch for on and off. Windows 1, 2, 3, 4, and 5. And the probe heaters. Engine eyes and wing and chassis. Here we have the electrical panel. Okay, this aircraft has 2 hydraulic systems, System A and System B, that you can see here. System A has one engine-driven generator, one engine-driven pump, and one electrical pump. The System B is the same, one engine-driven pump and another electrical pump. System B, normal, powered, the normal brakes and flaps. And System A, landing gear, alternate brakes, gear down, and normal steering. The primary flight controls are powered for both systems. And that's it.
Okay, so I'm going to give you a quick systems overview on the first officer side. Those are the controls we operate during the flight. Captain Telm just told us about the other parts of the aircraft, the one that normally the captain is responsible, captain's areas of responsibility. You can start here by the air conditioning system. Here we have the cockpit controllers. This one we control the supply duct, and here the passenger cabin. As you can see, right now it's indicating 24 4 degrees centigrade Celsius. That's normally when the flight attendants come and ask us to change the temperature. First of all, we take a look here, see what the temperature is indicating, and we can control it, whether automatic or manually. In the temperature controllers, the left side controls the temperature in the cockpit. We have the automatic controller, you can go here from full cold, full hot, and manually. Manually, we simply close or open the air mix valve. Same thing happens in the right side for the passenger cabin. Right here, we have our pressurization control panel. We have left, right packs, isolation valve, left bleed, right bleed, and here the APU bleed air switch. This is the position it should be on the ground. Both packs in automatic, both bleed air switches on, isolation valve open, and the APU bleed air open, so we can have air for engine start and for the passengers. Here we have our cabin control panel. This is the altitude we are supposed to fly. We were cleared for flight level 370, which is pretty high, flying to Santos Dumont Airport. And this is our landing altitude. Santos Dumont landing altitude is 11 feet, so I keep it at 0 here, so it can program the pressurization for during the descent. You have 3 control modes here. One is in automatic, the normal mode of operation. In case you have any problem in the automatic mode, we switch it to alternate, and this green light here will go on. In case you have, you also have a problem in the automatic mode, you can switch it to manual. Here, you are able to control the valve. You can go from the outflow valve. You can go from full closed to full open. Here on the ground, it's going to be always full open. So now I turn it back to automatic, which is the normal mode of operation. And here I have the cabin pressurization control panel. The inner scale indicates the cabin altitude. As you can see here in Campinas, field elevation is 2,100 feet. That is the same indication we should have here in its inner scale. The outer scale is the cabin differential pressure. If in any case during our leveled flight we have rapid decompression, the cabin altitude will switch to the altitude we'll be flying. Like if we are in flight level 370, the cabin altitude selector will go to 370 and the differential pressure will go to 0, because we will be at the same pressure at our altitude. And the max differential pressure per hold is 9.1 psi. This other gauge here is the cabin rate of climb selector. Normally, in automatic mode, it will operate at a rate of 350 feet per minute. And that's pretty much about it in our side. Thank you very much. Hope you enjoyed.